Okay, I think we'll get started. So today in lab we'll be talking about using the indirect file addressing. So we will write to a sequential set of memory registers with the indirect method, and then we will read from that as well. And so this will help us get familiar with the INDF and SFR register. So this is for indexing the indirect file references, and then the file selection register helps us run sequentially through the different memory registers. And this is an example of a pointer, so it's pointing to a memory address. Now, this was a hard topic to me, and it took a while to even get a little bit of it figured out, and so hopefully I can convey some of that. But again, this is a tougher topic, and I noticed that the example in the data sheet wasn't super complete and helpful if you're just first learning. So hopefully this will help, because we'll go in both directions. We'll be writing and reading actual values to the register. Now, what we're going to do is simply count in steps of 5, so 5, 10, 15, 20. In sequential memory registers. So we'll put this starting in 1, 0, and then 1, 1, 1, 2, 1, 3. And we could do this in a direct method by simply writing a literal to the working directory, then moving the working directory to 10, and then writing a new literal, moving it to 11, and so on until we fill out what we need. And that's a perfectly good way, and that's called direct memory accessing, or reading and writing. But we want to do this indirectly to get some practice with that. So what we're going to do is we're going to write to and read from the INDF register, even though this won't change itself. This is just point us to the different memory registers in the PIC10F200. Now, what we do is we set a starting point, and so we actually will take this as a literal, put it into the working registry, and then we will write that to the file selection register. And then as that progresses, increments up, so we can increment that by 1, 2, 3. That will take steps in the memory register. Its pointer will point to different sequential memory registers here in the memory. Now, what's important is the last 4 bits of the file selection register, and so 0, 1, 2, 3, and actually 4, but we're only going to need to worry about this here. So we're going to just use 4 of these, and so what we're going to do is we're going to flag on the file selection register to know when we're done writing this. Otherwise, it'll just keep trying to write to sequential memory registers. So we start. We'll tell it to start at 1, 0, and then with each increment, we will move along here. But that will change the value of the file selection register, and we will monitor. We'll always check each time if this value. So 0, 1, 2, if the number 2 or the third bit over, the number 2 bit, is equal to 1, then that will flag that, and that will get us out of this increment loop. Then we'll be done writing this, and then finally what we'll do is we'll come back and we will read this, and we'll read this to the working register and then store it in a free memory register. And in doing so, then we will add those up, and we'll finally finish with the summation of that, which would be 50. So let's see how that all works then. All right, so here we are in our program, and so this is a program to both read and write to in the indirect method for accessing the memory, so using pointers to the different memory addresses. We will write, as I said on the board there, in steps of 5, so 5, 10, 15, 20, to 4 consecutive registers, and then we read those values and some of those values into memory. First part, as always, this is the initial setup of the PIC10F200, and so this will always be the same every time. Watchdog timer turning off, and master clear enable is off, and so on. Now main is where we start. I've just put in some placeholder no operations here because we're not doing anything with the PIC IC right now, and so this might be where we would put our boilerplate to set up the GPIO pins on the PIC10F200 microcontroller. All right, so we'll enter our main loop. Now let me go ahead and I'll just go ahead and start running. I put a break here, so well, first I'll go ahead and build. We get a successful build here, and so now I will run the debugger, and we stopped here at this main, at this second no op here. So let's look at our, we're going to go back and forth here between the file registers and the special file registers, and then all of the file registers. The reason we need to do that is because in the file registers here, the working register doesn't show up. So we can see the file selection register, which is what we'll want to look at. We'll look at the INDF. Now what we're going to see is that the INDF doesn't change at all. So that's what I think, this is what I was confused about early on, is you're reading and writing to the INDF, but that doesn't change. It's just directing you to the memory registers that it's pointing to. And then the file selection register, this we note here the last 4 digits are what we're going to be, well actually really the last 3 digits are what we're going to be worried about. So we're going to watch that increment up as we progress through the memory registers. Okay, and then when we look over here, we're going to see we're going to start at register 10, and we're going to increment up to 13, and we'll store 5, 10, 15, 20 in that way. All right, so let's go ahead and step through. So we step through. What we're going to do here, we're going to move the literal of the working register. So the actual literal, the number that we have to put into the working register is the memory address. And so here the most natural form to work in is hex, because that's the identifying address there. So here's the hex version for this register. So we're actually talking about that register. Now that's just in the working register now. So we'll step through here, and now we're going to move this to the file register. So let's first check our special registers, and sure enough, we have added, here is that register in the working register, and now we will move this to the file selection register. So we'll step through here, and this has changed, and again we're all zeros. The last 4 bits are zeros here. Now what we're going to do is this, we're just going to put in the literal 5. This will be our step, so because we're going to take steps of 10, and we're going to just store that in 17. So this is just going to hold that value as our step value. So that's what we'll use that memory register for, because it's not one of the ones that we're sequentially writing to. So we'll do that. Let's go check that. And so, yep, there it is right here. We have now added that to register 17. I don't think this next step is necessary, but I just do a precautionary clear of the INDF. Notice here this is never changing. It was 0, always 0. Now let's add the working register to 17. So this should change the working register to 5, and maybe I haven't done it yet. Let's see. So let me look at the working register. Register is 5 now, and then we'll increment. We'll go through. Let's see. So the working register, we added 5 more, so now we're at 10. So the working register is holding the current counting by 5. So now we're the second step here. Let's look at the, let's see, we look here. We haven't, nothing has happened. We're still at zeros here. Now we're going to increment that, so that'll go to 1. We see the 1 over here. Now we're going to check this bit, the number 2 bit, so the third one over. So this is 0, 1, 2. So you got to remember you start with 0. So we're going to be looking for this one, flagging this one, and when we do that, we're going to skip this if it's set. Well, it's not set, so it'll come back through the loop. So we go back to the loop, and now we look at our file registers. Oh, I should have actually mentioned, yeah, so 10 has been moved into, we've moved over 1 now in our register, so 10 is moved into that. And then we'll take another step down. We're going to increment our file register. And let's look at our working register is now up to 15. We're going to increment our file register. So now that's 2. Was 1, now it's 2. This is still 0, so we're going to stay in the loop. Now we go back to our file registers, and this should now place that by moving that to INDEF. Notice INDEF doesn't change at all. It goes to the memory address, so it's pointed to that memory address. Okay, so we got one more time through the loop. I'll kind of go faster through that. So we go through the loop. Now we're at 20. We've got these all loaded. And now let's look at our file selection register. Here we are. Once we increment this now, we are here, and so we will, this is set now, so that should skip over this and get us out, break us out of that loop. So now we're out of the loop, and now we're going to, so we're done, we've stored, so this is the storage process, and so we've successfully stored the numbers 5, 10, 15, 20 in sequential memory registers. Now let's flip this. Maybe we need to read these values. So I'm going to reinitialize this no op here just to kind of transition now from the storing to the reading. Not necessary, but it just helps break it for us. So now let's start over again now. So we'll step into this. We will place 10 as our first register that in our sequence, and then we'll go back and let's move to our file selection register here. So let's take a look at that, and that has cleared it now back to 0. So we're starting over, but now we're going to read instead of write. Okay, so now we're going to move the contents of, in this case, 10 to INDEF as, well, we're going to move it to the working register via the pointer from INDEF. And so if we look at our working register now, our working register is now 5. And then we'll increment our FRS, so that has incremented up to 1. We're going to test this again. Well, the same flag as we used before, so that'll stay in the loop. Now the working register should go to 10 now. So we've moved this, we've added this to 10. And also let's see what's happening over here now. In 16 here, I'm going to add the working register. So this will accumulate. It was 5, working register is now 10, and we're going to add that, so that'll be 15. Right, so in register 16 is where we're going to store the sum. So this is going to sum all these. So let's go through, keep an eye on the working register now. This is going to change to 15. We're going to add this to 16. So it was 15, now we add 15, so we got 30. And our file selection register is progressing along. So we'll go through that again. Now our file selection register, our flag is on here, so that should just skip out. and we're ready to essentially end what we've wanted to do. And that will go back to the start. And so let's check our registers. So 5, 10, 15, 20, those have been held in that memory. So we wrote them there via indirect addressing, and we have pulled them back out via indirect addressing. And then just for the heck of it, we have accumulated the sum in register 16, and of course all the while register 17 was holding the steps, so steps of 5. Okay. If you wanted to step in any other value, you just change, in our case we would just change what was in 15. If you wanted to, maybe you wanted to multiply them all together or whatever, you could do that as well in the read step. So indirect addressing is just another way, it's a way utilizing pointers instead of directly writing to the individual memory registers. You read and write to the INDF register, and that can, along with the file selection register, controls which where the value gets written to or read from. All right, so that does it for this example, and so hopefully you got a little sense of how this works. Maybe play around with it, see if you can change it a little bit, and that's the best way to learn how to get this to work.